What's the link between software and your health? Hi, my name is Oded, and in this podcast I'll talk about software development in the field of medical device, pharmaceutical, and healthcare with industry-leading experts. In this episode, we'll examine what TDD is with the help of James Grenning, a thought leader in the field of embedded software engineering excellence. Hi James, thank you very much for participating in the podcast. Maybe we can start by you telling us a bit about yourself.
Let's see. I'll tell you the abbreviated long story. In high school, there were people, I had a friend who was programming and he showed me his punch cards. This is in the early 70s and it looked like a terrible thing. So I tried to avoid it. And then in engineering school, I had to write a program as part of calculus and I found out it was fun. And well, that's kind of led me to this day. I had the benefit and good fortune to work with some very good people. Early in my career, I started working with Robert Martin. Many people know Uncle Bob. And so we're longtime friends. And I learned a lot with him. And then in 1999, I ran into extreme programming, which has sent me down the path I'm on right now. And got involved in the Agile Manifesto, and I started applying the techniques of extreme programming to test-driven development, specifically to embedded systems. I'd been involved in embedded systems my whole career, and I saw that it was going to help solve some important problems, so I started investigating what to do.
Can you describe, before we dive in, what's your definition of embedded software? Is it software that runs without an operating system, like on hardware? Where do you draw the line that this is embedded software and this is just software?
Considering my chosen field is embedded software, I want the term to be as broad as possible. And so I look at embedded system not as the size of the processor or this, oftentimes there's tiny processors, or the size of the memory. Oftentimes there's tiny memories. I think of embedded software as something you don't recognize as a computer. So a car has millions of lines of code in it, and it's several computers, right? So you don't recognize it as a computer, but there's certainly computers as part of making them operational. And so that's what I use as a definition. And so again, with my chosen field of helping people in embedded systems learn modern engineering techniques, I obviously don't want to limit my market, do I?
Yes, I understand. That's very wise, business-wise, that's very smart. But if I take you further on that point, like, would you say that what is needed from an embedded software engineer is an understanding of the other parts, like electronics, mechanics, or when you take the example that you gave, like a car with million lines of code, I'm sure that there are parts there that the software engineer doesn't need to know about the other elements in the system.
Yeah, so typically a embedded engineer will have some familiarity with electronics. I have some familiarity. I'm not quite an EE, but I took a lot of electrical engineering courses. I've always ended up, being comfortable working near the hardware, looking at device specs. So that's usually something that an embedded engineer would be called upon to do. But by my broad definition, actually, one of the things that I've said before, and I'll work it in right now, which is we should build less firmware and more software. And by firmware, I mean the code that really depends on the hardware. And we want to build more software that can be moved from one execution environment to another. And so, the consequence of that is we want to have, we need to understand that area of the code right next to the hardware, but we also don't want to let the dependency on that hardware permeate too far into the thing that we're trying to do, into our product.
And to achieve that goal, you need that understanding of what's going on in the hardware to be able to make it software. That's the point.
You might need to know the what's going on in the hardware, or sit right next to somebody that does, sit near someone. I'll tell a joke, and I'm allowed to tell the joke because, what's the definition of embedded software? So here's the non-serious version. It's software written by double E's. Okay, so it's kind of a dig for a light insult, right? Because we're saying, oh, you weren't trained in software and you're doing embedded software. But I've got double E in my pedigree, so I can tell that joke without it being offensive. But oftentimes, embedded software is written by smart people that really don't have the experience and training in what and how software should be structured, right? And so I think the ideal embedded engineer will know something about the hardware and will also know a lot about how software should be structured so that as the hardware changes, and it always will, that we can evolve that software and move it more easily from one execution environment, hardware platform, if you will, to another execution environment.
I see you're putting a lot of emphasis on this. The software will change, that kind of continuous delivery mindset. Would you say that organizations that are making critical safety products, medical device, aviation, automotive, what should they take from this current engineering excellence environment where continuous delivery and modern agile is really the dominant?
Well, in a way, the thing that is now called continuous delivery. Well, we can't, an embedded engineer might say, well, we can't continuously deliver because we have to, reflash the device or whatever. So maybe embedded engineers feel like they don't need to care. Now, it should be a choice to be able to reflash a device any day you feel like it, rather than having it be a big event that you have to lead up to with a lot of safety checks, right? So ideally, what we should be able to do is be ready at any moment to release our software. Now, this is an ideal. It's going to be hard to reach, okay? But at any moment, our software, the things that are in it work, and it could be deployed to a device and run with the things that are in that software working, right? So the CI/CD, DevOps, as it's called, thinking would be very valuable for embedded engineers to embrace, so that we start to get control over when our products can be released. If I'll paint the picture, which nobody really does, a waterfall where all the requirements are done, all the design is done, all the code is done, and then all the tests is done, and then we release. Nobody really does that because, well, it doesn't really work. We iterate through all those different steps. Now, oftentimes we batch our work in too big of batches so that if we add a big new feature, we have some collateral damage, if you will. We break some other things while we're doing that. And so now I can't release my product until I've run it through a full regression system test, which might be manual and that sort of thing. What I'd like to do is get my processes under control so that as I make changes, I can be confident, will we ever be 100%? Probably not, but I can be confident that the things I changed are doing what I want them to do. And the things I didn't change are continuing to do what I want them to do. And these things work together still the way that I want them to do. I want my system to work on purpose.
What's the medicine? What's the forte to get there? And is it making your code with a lot of unit tests, a lot of end-to-end automation tests? How do you, all of the answers, how do you achieve that?
Well, it's hard. It is a difficult thing to do, but certainly one of the things is test automation at various levels, depending on, your needs. So, I wrote the book, Test-Driven Development for Embedded C, so I'm obviously going to promote that as a key thing to do. Now, do I do it because I wrote the book, or did I write the book because it's a key thing to do? And I'm going to go with the latter. I wrote the book because it's an important thing, which I never could have dreamed how important it was. And the thousands of people that take my training class, many of them tell me, oh, I had no idea that this was going to help me this way. So any of you listening, you have no idea how it might help you. And I could tell you, but you won't believe me. You got to find out for yourself. You got to go try it.
I hope there will be a discount for the
listeners.
For the listeners, yes, so we can.
If somebody listens to this and they want to attend my remote delivered training course, ping me and we'll see what we can do.
Excellent.
Okay. So what skills are needed? Now, one of the things about test-driven development does is it encourages you to work in small steps. So instead of writing code for a morning and then testing your code in the afternoon and debugging it the next day, what we do is we solve the problem of creating the software as a series of behavior-driven tests. So I use a FIFO as an example. So I have a brand new instance of a circular buffer, a FIFO. And how does it start out? Well, it starts out empty. Can I ask it if it's empty? Yeah, I can ask it if it's empty. And we just simply return true, and then the test passes. Now, well, if I put something in it, it's not going to be empty anymore. And so we're going to grow one test case at a time. I'm going to grow the behavior that I want. Now, this might sound daunting, but when you're writing code, you are growing that behavior. You just don't have confirmation that it works or not. And you're going to have to later go and find out what works and what doesn't work. With test-driven, what we're trying to do is make a feedback loop where every change is guarded by a test. Now, at the unit level, this is what we try to do. So we're doing thorough branch coverage, if you will, at that unit level. It encourages us to work in small steps. Now, why are small steps important? Well, small steps are important because we are really bad at programming. And if you wrote 10 lines of code, you probably have 5 problems with it. And, you've got to go find those a much more difficult way than, you have to go find them reactively because the mistakes you made are sprinkled in, randomly or systematically, potentially based on the kinds of mistakes we generally make. But your problems will have to be hunted down in that piece of code that you wrote. And that takes time. So instead, we state a behavior, write it in test. We see that the code doesn't do that. And then we add just enough code to pass the test. And then we think of another test. And so it encourages us to work in these small steps. Now, I'm sure your listeners have debugged some programs before. And so what are they doing? They debug. Well, they start working in really small steps. They look at, what happened between these 2 lines of code? Did the variables and structures get changed the way I wanted? Did we write to the right port on this device? Right? You start working in little tiny steps when you're debugging. And basically, test-driven is going to reverse that. And let's work proactively so that we don't have to debug. And that's one of the value propositions is that we could potentially cut back on debug time by being proactive in how we grow the software that we're creating.
So just to make sure I understand, you putting an emphasis on the writing the test, the unit test before the code as an alternative mean to debugging the code, right? That's like what you're saying. That's the main benefit of writing the test before writing it after. Well,
let me just say that's the most obvious benefit, because as you get into it, you're going to find out that there's other benefits as well. But the most obvious benefit is that you get your code to do what you want it to do, and it works on purpose. And you can do that without having to spend a lot of time debugging because of this short cycle. And it's not write all the tests. You might have a note card or a list of the tests you want to write, but you write the tests one at a time in an order which is maybe kind of a natural order, going from simple to more complex as you grow the behaviors.
Okay, and what about the higher level, the one with the specification that are like BDD, that they are in the user language, in the language of the user? I mean, so they are more describing how the product should work, and they're kind of more in automation that might require also the hardware. How do you see organizations deal with that challenge? Is it completely manual? Or?
Well, you might have seen or heard of the testing pyramid. And if we imagine a pyramid, the base of the pyramid is the unit tests. And what that means is that if you're going to take test automation seriously, the area you're going to write the most tests for are unit tests, so that what you get is a solid foundation of things that do what the programmer thinks they're supposed to do. All right. Now, the developers probably going to be wrong about what they think the code is supposed to do, but the code is doing what they think it's supposed to do. Now, that's for unit testing. The next layer up of the pyramid, kind of the middle of the pyramid, is what you're referred to as a BDD, behavior-driven development. Typically, like you said, in the language of the user, often in a given, when, then kind of nomenclature. Given that a light was scheduled to be turned on at 9 p.m. and it happens to be 8:59, then the light was not changed. Given that a light was scheduled to be turned on at 9 p.m. and it becomes 9 p.m., then the light was told to turn on, right? So we have this language that we could communicate to the system in, and maybe you would have the real hardware in there, or maybe you would have, as we call them, well, I'll just call them test stubs, smart test stubs. There's a whole name around them, or actually the official term is called test double. You might have heard mocks and fakes and spies. There's a whole vocabulary around these things. But we might have a spy light, a light that's being spied on, so that if the system said, turn on the light, we don't really turn on a light, but that interface that went right to the hardware abstraction layer for controlling lights, we would have gotten the message there that said, turn on the light. Now, testing that when you say turn on a light and the light really turns on, that's a different thing. There'll be hardware in the loop for that. But that's the peak of the pyramid. Okay, so the middle of the pyramid is the business rules. The peak of the pyramid is, well, when we said turn on light 14, did light 14 really come on, or did 13 come on because we were off by one, or 14 come on because we're off by one? What happened? Or did it turn off because we had the polarity backwards, right? All those things that could happen. I don't need to have that actual physical light in every single test, because the instrumentation for watching the light turn on and off, and the additional time it takes for that detector to see that, if it's a human or even if it's automated, through instrumentation, it's going to take too long to run all those permutations. So I don't really need to do it for all the tests. I need to do it for some. So hardware's in the loop for some. We can get hardware out of the loop for others, so that we could run tests about behavior of the system, and also marry it with the hardware and do tests that way as well.
I understand the emphasis should be on having a solid foundation at the unit test, and then the other ones, it doesn't mean that it's not important to automate them. It just become a less burdensome activity, maybe to say.
Yeah. And actually, I in every situation, you're going to have to decide, do we automate or not? And so, for instance, I have a website, wingman-sw.com, which I use to deliver my training, and I'm my own IT department, which reluctant IT department. I've never done a website before, but I've done this one, so it's kind of got some problems. It works fine, but because I'm learning about the environment and how to test in that environment, what I've done is I've added tests, now that I figured it out how to do it, added unit tests where it makes sense to have unit tests. I do have some legacy code, because when I first got it working, I didn't know how to work in unit tests in this environment, so I had to learn that. Integration tests, I typically do manually. So my changes, I'm the only person making changes, and I understand the system enough to know the scope of the change, usually. And so, like, if I make a change to a view, right, I just look at it and see, that's one of the things with views, you're going to have to look at them to see if they look right. And then the controllers in model view controller architecture, the controllers are, you press a button and it collects some data off the screen and then feeds a model. The model is where the business logic is. And so the bulk of the tests go into the model. And the controllers typically are kept simple. The views are kept simple, so that I can rely on manual testing for those. If my system gets much more complicated, I'm going to probably want to invest in some level of automation just to make sure that I don't break, commonly used links and things like that when if I make a big change. But usually I just make small changes, and then I'm able to confirm them and keep my system working.
Right, I see. And I want to take you to maybe a sensitive topic. I don't want to say there is blame game sometimes between hardware and software teams, but it's sometimes very convenient when a team is having some delays that they can say, oh, we are waiting for that hardware release What's your take on that? How do you resolve those
Yeah,
issues?
so schedule chicken, as we call it here. We used to play schedule chicken. You go to the meeting and everybody's like got a straight face, ready to play poker, and you don't want to be the first person to say you're not going to make the integration date. And I don't know, do you play schedule chicken? You're in Israel, right?
Yes,
Okay.
I think it's a universal game. I can't.
Okay. Well, so one of my first extreme programming projects, it was at a large US corporation, and we were doing a pilot of extreme programming. And there were maybe 5 or 6 teams that had to work with each other. And our one team was using iterations and stories to use cases to drive our work. And we would plan out, integration points at certain iterations and that sort of thing. We'd go into a planning meeting and somebody'd say, oh no, we're going to have to change the integration date because we're not going to be ready by such and such a date. And because we had gotten our process down and people were comfortable with moving stories around, because we did manage dependencies on hardware and other things out of our control, in the meeting, I don't want to say boss, but let's say product owner, which is the current term for that. Our product owner would say, sure, we can move that. One iteration out or one iteration in. And everybody else in the room was like, what? You mean, how can you do that? Don't you have to go back and rerun your PERT charts? He goes, no, we can just move it because, we manage our dependencies. It made all the other teams very uncomfortable that we could do this. And well, I must tell you, they eventually crushed the initiative too, because it's easier to stay with what you know, especially when you're frightened by something that was kind of radically different and effective. So
Very interesting story. I can't not ask you on that because you are one of the co-author of the Agile Manifesto. I wanted to know, I mean, if you can share. I mean, did you know you were making history? How did it happen? Why do you think
well,
it spread so?
well, you know where this meeting happened, right?
I remember the picture of everybody looking at the board, but I don't remember the location.
Okay, Snowbird, Utah. You know what Snowbird is famous for?
No, sorry.
Oh, it's one of the best ski resorts in the world. They get the best snow. And so when Bob Martin said, James, would you like to go to this meeting in Snowbird? Guess what I said? I said yes. And we had actually the name of the meeting was the Lightweight Methods Summit. And kind of the standing joke, which I'll attribute to Ward Cunningham, is we better change that name because who wants to be known as a lightweight? And so the name Agile came about, and we spent some time finding out what we had in common at this meeting. I was really there learning a lot from the extreme programming contingent. Kent Beck, Ward Cunningham, Martin Fowler, Ron Jeffries were the guys that we were hanging out with together, learning how to train people in those techniques. And so really I was there, kind of as somebody learning a lot from those, amazing guys that have innovated our fields. And with my special interest of bringing it to embedded systems. But did we think anything would happen in that meeting? No, I just remember Ward said, oh, I think I'll put it up on a website. And it's like, yeah, okay, nobody's going to care. And I was kind of surprised a few years later to find out that people really did care, and that it became an important thing that's kind of influencing our industry.
Maybe you can add to that. Maybe your 2 cents on why ideas really spread. Sometimes it's so fascinating for me that sometimes things catch and resonate so much with other people, and sometimes they don't. And maybe you have some insight.
Maybe. I think, as part of extreme programming, that's the world that I'm an advocate of. Agile is kind of a layer of abstraction on top of extreme programming or Scrum or feature-driven development or crystal clear, right? So there's this idea of let's find the lightest way to work that we can in our given area. Now, what interests me about extreme programming is the rigor in the engineering part of it. And I think, so why did it resonate with people? I think is, what you're asking. And is the logic chain from the problem you're trying to solve to how we're looking at solving it, is that a logic chain that I can pretty easily follow step by step? Okay, so for instance, what are the problems in the software development industry? Now, one of the questions that doesn't get asked much anymore, and I'm really kind of dumbfounded by it, which is, oh, we're adopting Agile. It's like, oh, great. Why? Because the management of the company said we're going to, or whatever it might be. Now, in early 2000s, 1999, why did we look at extreme programming? Well, extreme programming had a provocative name, so it's like, well, what's that all about? And they had a very clear description of what they're trying to do. And Kent Beck's words that he said, I'll paraphrase, trying to make the world safe for programmers and people that need programs. That's interesting. Okay, that's a weird take from an engineer. And Kent put together a Bill of Rights. And if you're not familiar with it, you get the little extreme programming book. The Bill of Rights says developers get to make technical decisions and business people get to make business decisions. Those are the foundations of those two. And then you could illuminate, you could list those out a little bit further. Developers get to guess how long it's going to take. And they should provide some idea of what it's going to cost to the customer. Customer can change their mind. Right? Okay, so now at the time, and maybe still today, the industry suffers from, late delivery and poor quality. And we've been known for death marches, right? For just make the people keep working until the product's good enough to release. I know some companies, this one company I did consulting with in the early 2000s, they would do their code freeze, say the annual release right before Christmas. And if they miss it, they're kind of almost out of business. Their code freeze was in April. And what code freeze meant, everybody furiously wrote code up until April 1st. I'm just making the numbers up right now. And then what code freeze meant didn't mean that they were going to not change the code. It means now they're going to start debugging. And they would work 7 days a week, would get 1 or 2 holidays off over the summer, through the whole summer, and working long hours, getting their code to work. Okay, so here they are, and then they might make their deadline, but at huge human cost, right? And all these people that have to pretty much give up their whole lives. So at the time, there's a lot of this going on, and there was, I think, a push by, maybe it was IBM, Rational, who was acquired by IBM. They were acquiring a lot of tools, and it seemed like processes were getting bigger. And we were kind of looking at, now maybe we need, smaller, more effective processes rather than bigger ones. What do we do about being late? Well, what if we worked on the most important thing first, and you could start to deliver value incrementally? Oh, that's interesting. Yeah, but what about retests? You're gonna have to keep retesting everything. Well, what if we automated that retesting, right? So that the cost of retest was zero. Oh, okay. So, and what about, you're going to be in a hurry. We need to spend more time thinking about it. Well, you're going to have these tests to be able to protect you while you redesign when you discover needs for new features. The test will, for the existing features will be there and protect you. It's like, oh, okay. So the logic chain for iterative and incremental work of the extreme programming approach, you could understand it, why it would have that impact. Now, it doesn't make it easy to do, but you could understand with a short logic chain of why the people that are doing it think it helps solve those problems of being late, of producing too many defects, and of having to, work around the clock and get burned out, right? So how could it prevent that, right? So that, at least from the extreme, I'm surprised that extreme programming hasn't taken off more, but I think that's partly because people don't understand. People understood Scrum is easy to understand. Oh, let's just start doing 2-week cycles. Now, if your engineers don't know how to do 2-week cycles, it's going to be painful. So we always started with extreme programming, and then the 2-week cycles are, extreme programming engineering techniques, and then the 2-week cycles become easy because you know how to engineer in small chunks.
Right. Right. It's more about the ceremonies than about really understanding how to get there
Yeah,
as from an engineering perspective. Then.
right. Yeah, and if I think of Ken Schwaber, I remember the first ever Scrum Master training class was at our facility in the suburbs of Chicago. And we said, well, Ken, why don't you have the extreme programming techniques as part of Scrum? He goes, well, I don't need to because we've got this thing called retrospective. And when people discover that they've got a problem, they're going to then go look for a solution. Right? It's like you're not going to discover extreme programming
How did that
that way.
work out 20 years
Well,
in insight?
you can go read the blogs. Like there's some article on Core about why do developers hate Agile? And if you look at all the answers to that, you're going to find out that a lot of engineers are very frustrated by we're going to manage you in 2-week cycles and have you attend a daily meeting. They're feeling micromanaged and not allowed to do quality work. What is missing from that equation is, how would you do incremental and iterative engineering, right? And make the short cycle deliveries work. How would you do that? And, once people learn it, it becomes, your life can get better, right? And if you don't learn it, you're just going to be unhappy the whole time because you're going to keep making your mess bigger and bigger.
That's fascinating. Really, thank you so much for sharing your wisdom with the community. Maybe you can just tell us to finish, how can people find out about your publication or other information about your course?
Thank you. Yeah, well, you could come to my website, wingman-sw.com. You could search for James Grenning and you'll find that pretty easily. My book is Test-Driven Development for Embedded C. I do offer training courses. I used to travel quite a bit all around the world teaching teams test-driven development for embedded C and C++. It's been a while now, a year since I've traveled given the current situation with COVID. I also offer a live via the web version of my training class. So instead of a 2-day on-site course, I spread it out over 3 days so that I can reach a lot of time zones. And I've got people in Israel that have attended my training class. I could make one convenient for your time zone. If people are interested, you can contact, go to my website and fill out the contact form, and we can try to collect enough people for a training course. If you don't mind staying a little bit late, I don't mind getting up early.
Sounds amazing. Okay.
And that training course is a series of cycles of explain a problem. So it's geared for engineers. Explain a problem, show a way to solve the problem, then let people do an exercise to try that idea out, and then we do a debrief afterwards to see what happened. And we do that cycle 3 times. I'm trying to also automate my training course into a self-paced course, which should make it more accessible to more time zones. So be on the lookout for that.
Brilliant. Thank you so much.
Oded, thank you very much.